Okay, guys, so this is today's lead code contest 357. Let's start with the first one or the second one. Yeah, this was the second one. Check if the possible to split array or not. Given an array and given an integer m, you can split the array into two parts, basically around one index into and then you got some new array, right? Splitted array. Then you go on that splitted array and then you can split that part, and that you have to do until you form n partitions. Basically, when you split all the particular indexes, all the particular elements into just one array of size 1, and if you have to do this, and you can only do this if the sum of subarray which is coming up is greater than m, or the length of subarray is greater than 1, sorry, is equal to 1. If the so basically if the sub array, basically if you divide this 2 to 1, why the answer for this is true? Because when you divide this into two parts around this index, this partition is satisfying both the condition that one part is having a length 1 and the other part is not having the length 1 but having the sum greater than equal to 4, so that both parts are fine, and then you can just split this because then both the parts will have length 1, so that condition is satisfied. And so that's what you need to do. As you can see, the code simple it is. You have to check for the adjacent elements. If there is an adjacent element which can serve as an ending point, basically before that I will what I will do, I will just take out one elements, right? So whatever the array might look like, if there are two adjacent elements a comma b, and there are some elements over here, there are some elements over here, I don't need to care about them because I can then separate them one by one. That is a good array, good splitting array. One by one, and until the point I reach a comma b, right? And similarly I'll split these part also one by one. That's very fine. Now ultimately I reach a comma b, that I need to split to make it all ones, all array of size 1. So a and b should have the sum greater than equal to m. That is the thing. Now before that, why there was no problem in splitting array? Because whenever I splitted array around this index, so that part was constant, like this part was completely constant, or at least this part was constant, that a comma b was part of that. So if a comma b, sum of a comma b is greater than m, so that makes sure that all the other arrays which I create after splitting also has a sum greater than equal to m. So that's what you need to do. If there exists a pair, you return 1. Question number was very basic, faulty keyboard. And this you have been given a string, and whenever I comes, you repeat the previous string which has formed so far. So what you will do, you will one by one create a string. Whenever you see I, you will reverse the string z dot begin z dot end, else you will just push back the character, and that's how you create the string. The third question is maximum elegance of k length sequence. So if I talk about specification of topic, first topic is just implementation string, second is implementation of arrays, and logic was just adjacent elements. This third question is a grid question matrix, you can see, but yeah, this is I believe DFS question, and the plan of action to do this question I can tell you is that first you go for basically you have to return solve of 0 comma 0, basically 0 comma 0, like what does this solve of 0 comma 0 means? What is solve of ij comma means? Which is, if you start from this point I comma j, what is the maximum, not a maximum safeness factor that you will get, okay, starting from this point? That is the thing. And you know that maximum safeness factor for what, you know anything? I know maximum safeness factor for something which is having, let's say, yeah, value equal to 1 for that index is equal to 0, because from there is no path to n minus 1 m minus 1 such that you do not touch 1, right? Basically what I'm saying, what is this question, what is this maximum safeness factor? You have been given a grid, grid values will be binary 0 1, and 1 means like there is some issue, okay, yeah, thief, I think, yeah. And basically you have to maximize your distance from 1, okay. What distance? The distance of basically of each element coming in a path from 0 0 to n minus 1 m minus 1 n. Yeah, this is just symmetric, so m is not something but n comma n goes k. So basically what you have to do first is you have to go for 0 0 to n comma n minus 1, or you can say if the zero indexing is there in the path. What you need to make sure that what elements are you taking between this 0 0 to n. So there is a path, right? There is a path p which you are following, and it will contain some of the elements like. Now, for each element, there will be some distance d1, d2, d3, d4, which is the distance from the nearest one. Nearest one, I'm saying nearest one, okay? So this d1 is the distance from nearest one for this first in the first point, second point, and so on till kth point, right? If path length is equal to k. So yeah, now you have to do is basically you see what is the maximum or minimum in this, okay? What is maximum d1 among d1 to dk, because that is the minimum distance of a particular element coming in a path from a 1. So that make sure, and then 0 comma 0 and n minus 1 n minus 1 also you can count that also as your path key. What is the distance for this from 1, and what is the distance of d of, let's say, n minus 1 right? So this is the thing. And after these all the distances you got, like these are the actual path from 0 to n minus 1 which you are following. You see what is the minimum of this, d0 to dn minus 1 or d, yeah, dn minus 1, yeah, final, whatever you can call it, d final. And whatever is the minimum that you need to return, because that is the like something like in a path that is very closer to 1, and we do not want that, but we cannot, yeah, like there is one, so there would be some distance from 1 obviously. As you can see in this path, what is the minimum distance from 1? This point has a minimum distance of 2, this point has a minimum distance of 2, so that's why we return 2. And in this path, what is the minimum distance? Actually, the path, any path you follow, even if 0 or this becomes 1, then you simply return 0 basically, yeah. Any path will be passing through 1. So in this path, what is the minimum distance from 1? This is distance 2, this is distance 2, yeah, so on. So distance 2 is minimum, so that's what we need to do. Now how will we do this? First of all, we will call on solve 0 comma 0. That will basically say ki all the paths, explore all the paths. We will explore all the paths from 0 comma 0. We will do a dfs on 0 comma 0. And we know what are the points we can go. We can go to a plus 1 b comma b, a minus 1 comma b, and a comma b minus 1, and these are the 4 options that you can take. And then you say ki bhai, starting from that point, a comma a plus 1 comma b, or these 4 points, what is the starting from this point and having a path till this, right, n minus 1 n minus 1, what is a, yeah, path you get, what is a minimum dx you get in the path. And then 0 comma 0, you know what is the dx, okay, obviously. So that is again gonna be uh, yeah. And between all these paths you have to take minimum or maximum, you have to take maximum, right? And this is the path after this point, but this is this point. So there can be like you have to take maximum of this point comma whatever comes after this point, right? So that is what you need to do. So after this, basically for this is the distance ab function. It can be implemented as a function which I'm doing, or it can be used doing some pre-competition which you can do. From each one, do a multi-source BFS, and for complete grid, find dx comma dxy, right? Where dxy represent the, yeah, the length, yeah, minimum distance of a nearest one for the point x comma y, and that can be used over here. And that's what you need to do whenever you reaches this n minus 1 n minus 1 you distance of whatever this point has. You return that, because now you don't need to call, but the only thing is that now you don't need to call on anything else if you already reached this point. So there's no point of calling something else. If you go out of the bound, you return 0. So that key, yeah, like did you return 0? Yeah, you can return 0 key. Yeah, this path is not so good. Like obviously in that way, it will not go further. And yeah, and that's what you need to done. Okay, let's see one of the sample thing which I'm saying. So just kind of a implementation question and DFS question. I will say two BFS or DFS, whatever you can run, DFS plus BFS. My search because I don't feel any. My search you can do क्योंकि minimum maximum कितना हो सकता है, like maximum अभी 0 तो हो सकता है, maximum आप इसको 1 से कितना दूर कर सकते हो, कोई भी 1 कहीं पे भी प्रेजेंट है, ठीक है, n प्लस n से तो ज़्यादा नहीं कर सकते बिकॉज ये और ये तो आएंगे ही। तो या मैक्सिमम आप n प्लस n, बाइनरी सर्च का मतलब है कि मैंने मान लिया डिस्टेंस, क्या वो डिस्टेंस सेटिस्फाई करा सकता हूँ मैं। ओके, सो फ्रॉम ऑल द वंस तो ऐसा पाथ चुनना है। ओके ओके, सो मल्टी सोर्स बीएफएस करो ऑल द वन से, जो डिस्टेंस तुमने के चूज करा है, और उस पे जाके सबको या सारे सेल्स को मार्क कर दो, एंड देन सी कि मार्क सेल्स फॉर्म पाथ बिटवीन 0,02 एंड -1. So as you can see what they are doing. If it is 1, then you push that. Safeness factor is certain value, so if the safeness factor is given, you can find that part. Okay, so yeah, you can choose a particular value, and then from 0,0 you only move to the cell if the distance factor is like yeah greater than or equal to x, and that is already calculated for each cell. And yeah, binary search on the answer if it's possible to reach, try for this. This is the part where they are doing like calculating minimum distance. Then you do your binary search, then you say 0,0, and this is the final. That should be doing well. For all the neighbors, your grid has to be greater than val. Yes, so that is what you can do. Wherever maximum minimum comes, you can apply binary search. So basically, choosing out all possible ways will not be so good. Or you can, based on the DP, if someone is applying DP. Okay, so this is the part when we calculate that. Okay, okay. So that was the third question. Implementing DFS would not be so optimal because you go for yeah, like it is not even exponential. Every time you have four options, so 4 is to the power x, and yes, and calculating distance in that way is also not fine. But if this can be done by using that, there is no issue with this. But then okay, so then we can go about binary search. Whenever this maximum safeness factor comes, maximum minimum kind of thing comes, you have to basically restrict something, or there is a linear fashion. Like linear fashion, I means like maximum I need to find maximum which is valid. After this, if you take one more step ahead, it will become invalid. So this is the point where is the maximum valid. So you try to find out this thing, because before that it was valid, after this it is invalid. So this is the last index where it is maximum safeness factor. Okay, kind of thing. So yes, so you find out that by search on n, and you see that okay, starting from 0,0, I will only take those things which have safeness value greater than equal to m, or whatever d you have like selected on your binary search thing. And then you try to go over that. If that is possible, then you try to look for more bigger values. I want to make more distance from one. Otherwise you just make less value, like by going dividing in half. Not exactly dividing in half, but if LHM, okay, LHM, you have this left part, high part, and n part. If m satisfies, where you make your l is equal to m plus 1. If n does not satisfy, you make h is equal to m minus 1. So yeah, basically then you search in the l to m minus 1 wala range. So that can be done. Okay, chalo, okay, bye.